The last rule we have to familiarize ourselves with, it's called the chain rule. It is arguably the most important rule you need to know for differentiation. However, to fully understand this rule, we might want to first spend a little time on the concept of a composite function or chained function. The trick is to try to disassemble an existing function into the successive application of two functions. So what does that mean? As an example, if I show you a function like this, h of x equal to e, yes, we do like the exponentials, but not just e to the x, because that would be too simple. If I now ask you what is h prime of x, you would answer me in a second, it's just e to the x. But what if this x becomes an x squared, or e to the x squared plus 1? So what does that mean? I'm raising e to the power of this whole thing. Let me write this in brackets. Now, we don't really know how to differentiate such a function because we haven't learned a rule for such a construct, and we can never learn special rules for all the possibilities there are. So instead, we will get to know this general function, the chain rule, that attempts to rewrite h of x as two functions. Namely an inner and an outer. So what does that mean? We could now define this one here, this x squared plus 1, as my inner function, which it really is. Inner function, and we call that g of x, and e by itself is my outer function. So you should look at h as a composite function. What does that mean? I'm plugging x in, I'm plugging a value for x in. So I first apply inner function, which is g of x, and whatever comes out of g of x is then plugged into the outer function, f of x. So you should think of this as two successive functions. X goes into g of x first, and g of x then goes into f. But now I do not want to write f of x because that would be confusing. X is the original value all the way. So let me call this f of z. What that really means is I'm plugging g of x in as a new argument for f of z. So I'm ending up with really f of g of x, and that whole construct is h of x. It's a composite function. So if you're able to either recognize what is the inner function, what is the outer function, and if the derivatives of these two functions by themselves are easy, which they are here, notice that if I asked you what is d dx of x squared plus 1, you could answer that, and if I asked you what is d dz of e to the z, you could answer that as well. So you just need to learn how to combine these two derivatives, and for that we have the new chain rule. So let me put a big bracket, d dx of the composite function. So I put a big parenthesis first, and now we first have the outer function f, and inside sits another function g. And we hope that the functions are chosen the three sets of parentheses. I should have made this square. And here comes the rule. The rule is easy to remember in words. Outer times inner. Outer times inner. What does that mean? That is simply outer function f prime, where in the step of taking the derivative you ignore the fact that there's a g of x in there. Yeah, that's what that means. So f prime of, but now when you're done with the prime, you plug g of x right back in. F prime of times inner. Now the inner one is g of x, so inner derivative is g prime of x. That's it. Yeah, this looks big, and but is probably the most useful rule that you will learn in the context of differentiation. So let's try to apply this rule to that particular function. So what would f prime of g of x be? So d dx of e to the x squared plus 1. This is my g. So my outer derivative is just, again, the exponential function. So that is unchanged, x squared plus 1 times the inner derivative, and now g of x is just the x squared plus 1 part, which leaves me with a 2x.